Thank you. All right, so thank you for coming. This is a talk. So the talk is on reversing client-side JavaScript using the Chrome DevTools protocol. And we'll see what I mean by that in just a moment. Should be fun, hopefully. So I'm a father and husband. I'm a senior application security consultant at Invisium. Basically repeating stuff. Just worked as a security engineer for a small SecOps team. I worked doing primarily as a developer before that, working on .NET, Angular, and other stuff. It was consulting as a developer, so it's a bunch of different stuff. Did other stuff before that, mainly help desk, boring stuff. I'm a fan of the Go language. And I like messing with fancy frameworks like Angular, things like that, and also Microsoft stuff. So some disclaimers. Nothing in this demo is illegal. I don't think so anyway, and really hope it isn't. It's just front-end behavior that I'll be playing with and messing with. I'm not modifying server requests. I'm not doing any sort of exploitation. Just exploring code and exploring front-end functionality. Cool. So might sound kind of weird talking about reversing JavaScript, since it's not like we're running a immunity or disassembling a binary. So what I mean is basically conducting in-depth reviews of front-end code of different applications in order to, and for that it is necessary to, a lot of times, to understand minified or Webpack code that can be very difficult to make sense out of. This can be accomplished through dynamic debugging in the Chrome console. And then one of the things that I wanted to do too as well to help me explore JavaScript applications was to inject JavaScript code in helper functions. And this is something that I found that I wanted to mess with when I was doing different types of penetration testing assessments for applications, where basically I will look at the front-end code and then think or have a suspicion that something is just being handled on the front end. Then if I could bypass certain validations there, I could see more functionality and things like that, just because they were not doing maybe the sufficient work on the back end. So also wanted to modify JavaScript code on page loads and inject my own helper functions and set breakpoints based on server requests, calls, and things like that. And in doing so, then you are basically getting an understanding of how an application works from the front end. You're able to see the code in a more clear manner. And then from there, you can explore different functionality and try to see what interesting things you can do. So a lot of times I open up as a penetration tester for applications primarily. I open an application. If it is completely dynamic, the assessment, meaning I don't get the code for doing any sort of static analysis, then this is what you usually get. So newer applications have all their JavaScript code minified at the very least. If not, they're just using Webpack to just basically bundle every single JavaScript file that's being used into one nice compressed file. And that makes it kind of hard or very difficult if you wanted to do in-depth reviews of front-end code. So then the goal was to understand how a front-end application functions at the code level, modify code as needed, test client-side vulnerabilities, and to test for missing functional level access control at the backend level. Doing this by eliminating client-side restrictions through modification of code and things like that, that do things like validation and apply security bias security too. So meaning maybe there are front-end controls that are preventing you from seeing admin functionality, but then that's all that's in place. It's just front-end stuff that you should be able to bypass. So what do we want to mess with and understand front-end code anyway? So more applications are using fancy, first of all, they're relying on full-stack developers who can write server and client code. Sometimes this makes it easier to write bugs by omitting server, but by omitting some security measures. The ability to examine front-end code in depth can find these kind of bugs. And as a developer, I've made dumb mistakes myself, so I know that there are things that, mistakes that are easy to make as a developer or as a full-stack developer. Also, many front-end frameworks can be complicated, but then those solve like Razor or jQuery as far as client-side stuff. I hate Razor. Complicated JS frameworks can easily mask very accidental security bugs. And like I said, I have written such accidental bugs because you're jumping between front-end stuff like writing Angular, then going back to .NET, for instance, and jumping back and forth, and then you might miss something and a half. And I also figure it will be fun to find these bugs by reversing front-end functionality. So I kind of gave up with the idea of doing anything interesting there. I just continued doing my typical pen test work. And then I saw this article that I thought was pretty interesting by a guy whose name I should have probably remember, but I suck at names. So his name, I don't know where it is. It's right there, the username. It's, the article is intercepting and modifying responses with Chrome via the DevTools protocol. So he basically explained how in his company, Shape Security, I believe it is, they use this thing called the Chrome DevTools protocol to modify requests and responses from applications. And they do this a lot of times when they're doing things like IR, incident response, and trying to look up malicious functionality that might be embedded in the code in legitimate functionality of applications. So I started looking into this. Then I learned about the Chrome DevTools protocol, which I thought was pretty cool and awesome that I hadn't heard about it before. So it allows you for tools to instrument. This is from the definition of their site. Allows for tools to instrument, inspect, debug, and profile Chromium and other link-based browsers. That I'm not sure what that means, but also from the project, basically this instrumentation is divided into different domains. The main ones being DOM, the debugger, network. And each domain can find a number of commands. Basically an API, and it supports events and different events as part of that API that you can hook to and do things like intercept requests, modify responses, inject code, and things like that. So projects like Puppeteer and other headless Chrome tools leverage the Chrome developers DevTools protocol. Puppeteer is a tool that for developers to test and debug their applications at the front-end level. So running things like automated actions that a user will go through to and then test whether an event happens or not, for instance. Using a typically headless Chrome instance. So browser extensions for inspecting JavaScript for JavaScript framework usually leverage this as well. So things like if you have ever worked with Angular or React and you install one of those inspector tools that are available for Chrome, where you open it and then it tells you things like the Angular services or React components and things like that. So I figured why not use this for pen testing and bug hunting. So that's what I did. A little bit more about the DevTools protocol domains. These are the main domains that we can work with. So we can basically hook into the data that's being sent and received by Chrome. So there's a network domain that allows for tracking network activities on the page and gives you information about the HTTP protocols being used when a request is being sent, headers, the content of a request, timing, etc. It's a page domain, which is based on actions and events related to the inspector page, and a runtime domain that exposes JavaScript runtime by means of remote evaluation and mirror objects. So each domain has its own set of methods. So the idea is to basically use this as a way to dig deeper into applications. Then I wrote this tool called Gorp, which is a dumb name, but this is what it is. It's a plugin-based Golang framework, and I'll explain a little bit more about that in the next couple slides. Uses the Chrome developer protocols to modify application behavior, automates research tasks that can be painful to conduct with Burp. So, and hopefully I can clarify that later. It's extensible via plugins, meaning Go plugins. It uses Go, so concurrency is pretty easy if you need to write concurrency in your plugins or code. And I've been wondering whether I should call it Gore instead. But then I'll be worried about it too as well. So anyways, how does it work? So it's basically a Go-based application that opens a Chrome instance with 2 tabs. All requests and responses are received. That are received sent and received are captured using the Gorp debugger. So it's a debugger engine written in Go. So once a response is received, those are passed to processors or that are actually plugins in a sequential manner. They're also sent to this other plugin type called inspector in a non-blocking manner. So you can inspect scripts for interesting information. It also loads custom scripts on every page load within the context of the application scripts. So basically, you can load JavaScript code that messes with the system functionality of the application that you're loading in your browser. And it sets event-based breakpoints to allow us to debug applications. This is, hopefully that won't give a seizure to anybody, but this is the basic architecture of how it works. So this is Gorp. It uses different plugins, which are compiled as Go plugins, and uses that as modules. And then everything is being sent and received by the debugger. And then from there, we can do any kind of manipulation of the request using the plugins. This is an API that it uses for just common tasks. So it's a lot of talking here. We'll get to demo soon. The Gorp plugins are essentially modules that you can modify to other web responses. There are Go plugins, so it's easy to extend functionality. So basically, Go has this thing that you can write a few functions, for instance, and then you just compile that as a Go plugin. You just pass, when you compile your Go program, you pass it certain flags to compile it as a plugin. And then your code can leverage those plugins in whichever manner, as long as you know what functions have been implemented there. So they just have to implement an interface that you define for them. There are 2 types of plugins. There are processors, which alter the response before it's rendered in the browser. This can be useful for things like modifying JavaScript code, changing HTML directives, or hiding elements, things like that. And the inspectors conduct analysis on responses concurrently. So for instance, if we want to record all references to API calls made by the applications, then the responses get passed to the inspectors. The inspectors look for API references and then record those in a file. I gave a similar presentation to this in B-Sides this year here in Austin. This is one of the main things that I added. It's the added Gorp runtime debuggers, which allows you to inject custom code for dynamic manipulation of application variables and functions. So if you have always wanted to, instead of having to copy and paste code into the Chrome console, you can just have a file with all your JavaScript code that you want to run within an application context. And then it will be executed on page load. Also, HTTP request-based breakpoints and other breakpoint options are a work in progress. This is the repo. So it's just Dharma code /Gorp. Has a little bit of that documentation. I try to keep up with that. Sometimes I'm lazy. I'm trying to add more documentation. So this is how it works. You basically create a config file. That's a YAML config file. Then you select whichever processors, plugins you want, or whichever inspectors. You give it a path, and then you run it. And then if you are writing your own plugins for this tool, then you can just compile them running some of these options that are here. Run Go, or just run Gorp tag P. All right, there are some demos and lower your expectations. That was a lot of talking. So the first demo is it's one of the most useful ways in which I've used this tool before, and it's to force Angular 2 and above applications to run in development mode. Why do I want to do this? Well, Angular 2 plus apps are loaded usually. If they are production apps, they are loading in production mode. Apps loaded in debugging mode are easy to reverse from the console, unlike Angular 2, unlike productions or applications loaded in production mode. So, and that's because the debugging element tree for Angular, it's only available for applications running in development mode. They don't run on applications running in production mode because that it's additional processes that will be running behind the scenes in your application. If you see, now there's only one specific function that once you run, you load an application in the browser that's running in Angular 5. There's one single function that enables production mode for an application, and that's this. So this is from the Angular repo. And all it is basically, there's one function that just says enable prod mode. And that gets run as soon as your application loads in the browser. So, and this prevents us from being able to debug and understand an application and see how it's written from the console. And we'll see that in just a moment. So then what the plugin does, wrong button, is to look for that function, modifies it so it does nothing. That way the applications that you load in the browser are loaded in development mode. We just hijack and rewrite the function. This enables the Angular debugging tree. Now you can do this manually using Burp. So you can just capture your request, search for that string, cannot enable prod mode as the platform setup in the minimized code. You locate the function in the code, you capture it in Burp, you rewrite it, and you release it. But that's a lot of work. So that's one of the things that the plugin automates. You just have to add the plugin to the config file, and then, and this is a demo. I just realized that that's pretty small, so we'll see how this works. But basically, this is just me running. Just make sure to play it. This is just me running Gorp, the tool, to mess with Office.com, which has a bug bounty. So I'm sure this is OK. So basically, when you Office uses Angular, I forgot 7. In that case, when I made this video, And then what we should be able to do is basically obtain a variable that holds the state for the application using this function ngprobe. That's super little, I'm realizing as well. But we get null because the application is loading in production node. We don't have all the debugging functions available for us. So we just create a configuration file for Gorp that includes the prod mode hijacker plugin, and we enter it in the config file. You can get the definition for what the plugin does if you want, and then, like I said, you add it in your config YAML file. Then you just run it, the tool, and then, like I said, that launches a Chrome instance. And this instance is hooked to the Go code for Gorp. So then we're trying to see if the function got hijacked. It didn't get hijacked in this case. That's because there's some cache that we need to clear because we need to reload those scripts. So we just reload office.com, and then we get this nice message that says the enable prod mode function was hijacked. And usually the end result is that the application is running in development mode. And at this point, we can then obtain using $0 that selects a currently selected element that we selected in the inspector. Then we can obtain more information with ngprobe, taking advantage of the debugging abilities that are included as part of Angular. So then that gives us, for instance, in this case, we can get, first we're going to grab a component. This is an Angular component. And then just by using the console, we can get a better understanding of how the application works behind the scene. So here we get all the services that Office.com uses, and then we get different things that we can leverage from the console, which wouldn't be possible if Angular had run in production mode. So in this case, for instance, we get the user base key, and then we can modify it. Then we run a couple other functions to apply the modifications in Angular. And then from there, we just basically continue playing with the different variables in the application to see what changes we can cause from a client-side standpoint. So there, we can, for instance, change the tenant ID and see if we can prompt the application to do anything interesting. Yeah, we just changed it to a different tenant. All right. Next one is, nope, I'm not doing the next one yet. So I'm not going to run this demo just because the last one seemed to play OK. I might go back to that one if the next thing that I'm going to do doesn't work. So in that demo, there was a lot of me going back to Visual Studio Code and copying functions to help me debug the code. And that was a lot of work, so I wanted to leverage custom code rather than having to copy and paste all the time. Custom code in the console, I wanted to run that on every page load. And I wanted my code to be, my custom JavaScript code to be aware and work with the other functions that are loaded as part of the application that I'm loading in the browser. So what we can do basically to do that, and I'll end this for now, and I'm going to do an interactive demo. So hopefully this wasn't a bad idea. So we go to the config file and make this crazy bigger. No breakpoints, please. And then we can do a couple things. One thing that we can do is set breakpoints based on post and get calls. So you basically tell it, set a breakpoint whenever a get or post call is made to v1/logs. And I'll just keep that one there. But you can add other breakpoints based on the path for a get or post request. But in this case, we're just going to keep v1/logs. And then the other thing that we do is we pass it a file with custom JavaScript scripts and functions. And we tell it to keep a watch on that file for new changes. So then that file is this one on the side. And then what we do basically is we define a function called Gorp that Gorp is going to look for. And then in there we can register all of our custom functions. And in this case, all I have is basically some functions to help me mess with Angular code. And then I'm defining them as variables first, and then I define the function, depending on whether it is an Angular 1 application or Angular 2. So I have my custom code ready, and then I can just go and run the tool. And this opens a new instance of Chrome. Just making it bigger now. And then everything that we enter here, it's going to be processed by Gorp. So if we go here, this is another application that has a bug bounty, so should be OK. So I'm going to log in with this login that I'll burn after this. Cool. And then here, the code that I wrote in JavaScript was able to detect that this is a Angular 1.7.8 application. And it makes these functions available for us. Get all services, apply changes, and get specific service. These are the variables, and all this is because of the code that we had, or the custom code that we had here. So now let's say that we want to get all the Angular services that are running for this application. So we do, just to not mess things up. We put declare a variable called all SVC, and we call the function get all services. I'm passing it the name of the application, which in this case is LOB, which I know by inspecting the code here, there should be an ng app equal LOB. Oh, here you go. So then that gives us all the services that are available for this application. And then the first thing that we notice is that we get for every service, there is a services in Angular are typically used to call your APIs as well. And in this case, we have URLs for basically one URL for every service. And that URL corresponds to an API endpoint. So that makes it interesting. We're able to examine, even though the code is minified and we cannot make too much sense out of it, we can start exploring how things work from here. So we can just write a quick, since we have all the services stored in this variable, we can just run a quick script just to see if we get the list of all the endpoints. Now, of course, you can get this type of information by exploring an application and capturing API endpoints in Burp and start messing with those. But it can take some time. So for instance, if it's an Angular app and you just run these custom functions, then you can very quickly get a list of things that you want to start attacking or checking or assessing in your application test or assessment or whatever you want to call it. So the other thing that we can do from here, it's again, we can print functions and be able to better understand them rather than look for them in the source of Chrome. So we can just simply just print the definitions of functions. In this case, we're printing the definition of verified email. And then we can read how that looks like. And then we can also make modifications as needed. So if we needed to do things like services.user verification.verify, and we can just rewrite it, of course, without caps on. So that's the ability to inject code and how that helps in debugging an application. In this specific case, in Angular 1 application. So if we go to, in this case, I also have the prod mode hijacker code enabled. This is, again, the one that I just demoed or showed in a moment ago. If we go to a page like delta.com, and then in this case, it detected that it was, first it removed the, now it's running in development mode because we have that plugin enabled. We get this message, which actually comes from Angular, telling us that, hey, this is running in development mode. Why did you publish an app in development mode? Then it also tells us that it's running Angular 2, and it gives us a set of functions that we can also use to select the different, or start debugging the application and being able to understand the code and do similar things like with the ones we did a moment ago with the Angular 1 point something application. So let's continue here. And that was me crossing fingers for the demo I just showed. Another thing that you can do is hijack functions. So basically, you find a function that is loaded for an application, and you can modify the content, which is something that I found useful in some applications. It's usually, and just a caveat or just something to note, I guess, is that I don't use this for every assessment that I do. I just use it for applications that I have a lot of time to spend messing with, or applications where I don't have the code for, and applications that I like, for instance, a powerful bug bounty. So I can just spend time playing with the application as much as I want. Oh, back to this. So hijacking functions, that's a different plugin. You just basically add these options here. You put the function name in the config file, and then you declare a new body. It finds a function, given that hint that we gave it here. In this case, it's logged in. It's useful to test missing function level access control vulnerabilities. Can be used to skip validation, buried inside multiple function calls. Can be used to force apps to think that they are logged in or have admin rights. Useful when you need to verify request formats. And let me actually pause here for a second and go back here. And I'm going to go back to lob.com because there's something I forgot to mention. Let me see if I am logged in. Yeah, dashboard. So we said that XHR base breakpoint. So that makes it so that when we call, oh, here. So when we go to API logs in the menu, then it does a call to the v1/logs endpoint, API endpoint. And this basically, because we told it to stop whenever a call is made to that, then it makes sets the breakpoint, and then from there we can examine the call stack. We can examine the variables that are part that are loaded, the local variables and things like that, and their contents. And there are some things that are not working perfectly right now, but you get the idea. So the function hijacker plugin, this is basically what it does. You just open this. So in this case, I'm just using Juice Shop, which is just a part of the OWASP project for intentionable vulnerable application. So in this case is just a login page. We don't know where to start, what email address to even input, but we want to see what is available to an admin that we cannot see, or even just somebody that's logged in. So what we can do here is basically we locate the path for the JavaScript file that we want to look for functions and modify. But what we're going to do is basically, and here's the function, is logged in. And is logged in basically just checks whether we have a token, a JWT token, to indicate to the client-side code that we are logged in. It's a very common logic used by applications like Angular and anything that just uses JWT tokens and an API for an application. So we just basically add the option in the config file to enable that plugin. And what we're going to do is not just modify a function. We want to replace the entire JavaScript file with one that has our own custom code. So we go here. And it's taking a while. Rather than and then we give it a new body for the function is logged in. Give it a console.log for is logged in that just says would in this case. So, and we return true, just so it tells it that, hey, yes, the user is logged in. Please show him or her everything. We run Gorp. In this case, it's not the one that we're modifying the entire file. That'll be a different demo in just a second. But we're just modifying one function here. Then we load JuiceShop again. And then the is logged in function, it gets called by the application. But because we modify it, then we get all the console.log messages that we injected. And then we get all this other menu functionality that we can start messing with directly. Because we tricked the application into thinking that we are logged in. There's also a injector plugin. This I won't have a demo for, but basically it allows you to inject additional code within a specific function. You just pass it the function name, and then you pass it additional content that you want to tag at the end of that function. So it's helpful when you want to test when a function is called via console.log messages, for instance. There's also a inspector plugin that allows you to record references to API strings in JS code and saves them to a desired file. So for instance, go back here. So I had the inspector plugin for the API finder already enabled, and then that makes it so that our API, any strings contained within code, is entered here in this file. That gives us an idea that there's a possible. This is me testing account.xbox.com with an account that I don't really own. So basically, we get some ideas of the different APIs that are being called within the code. So I can do an API finder demo, but it's just pretty simple. You just launch Gorp, and then you add the plugin, navigate different sites, and then as API endpoints are found or located within code, those will be saved to this file, or the file that you specify. The next one is a on hider. This is just basically reveals elements not removed from markup on page load by Angular via ngIf and ngF. These are basically Angular 1 and Angular 2 and above. And there's a find and replace plugin. You just give it a string, just a simple find and replace. Give it a string of things to find in code and replace it with. I could do a demo for that, but And actually, in this case, rather than just giving it a, let me just make this bigger. What the plugin does, in addition to you being able to pass it a string and a find and replace string, is to also give it a complete file. So like if an application is loading React x.y and you wanted to run use React z.y, you can just give it the path of the file for the file that is being loaded in the application, and the path for a local file that you're storing locally in your computer that has possibly a vulnerable version of React or a code that you have modified to trick the application into doing different things. So in this case, we just go to the file while all the scripts are being loaded. We get the path, so copy the link address, we paste it in the URL for where the file is located. We give it then the path for a local file that has all this custom code where I enter a bogus username. So the application is always thinking that I'm logged in no matter what. So I changed it everywhere just to make JuiceShop think that I am logged in. That's a lot of pointing, but cool. So then we can copy the path for that. We put it as part of the options for the plugin, and then we run the tool. There we go. So then when we load JuiceShop again, then JuiceShop is going to use our own custom JavaScript file rather than the one that their developers wrote. And then this allows us to see all this other functionality that's up there. It assumes now that we're logged in, so even if we go here or to contact us, it's going to show the username that I selected by default and put in the code. So that's that plugin. You can also write your own core plugins. It's pretty easy, but I haven't seen anybody do it yet. But basically, you have to, if you are into writing Go, you just write a processor or a code file that adheres to these interfaces. So if it is a processor, you have to implement these methods. If it is an inspector, you have to implement these methods. Every plugin gets past this web data struct or object that has a body, headers, the type of the request, and the method. So it will tell you whether it's a post or a get. And based on that, you can do different logic. And that's it for now. So I'm working on additional plugins, focusing on code debugging and being able to further understand applications from the front-end side of things. And if anybody's interested, the code it's out there. It's just a fun project. So that's it. If any questions, let me know.